Hello, and welcome to today's webinar, The Chemical Class Approach Towards Healthier Products and People. I am Dr. Barbara Malkus, Board President for Massachusetts Breast Cancer Coalition, and I'd like to thank you all for joining us today. Massachusetts Breast Cancer Coalition is dedicated to preventing environmental causes of breast cancer through community education, research advocacy, and changes to public policy. I am pleased to welcome today's speaker, Dr. Arlene Blum. Dr. Arlene Blum is the Executive Director of the Green Science Policy Institute and a Research Associate in Chemistry at UC Berkeley. The Institute's scientific research and policy work with government and business has reduced the use of classes of harmful chemicals, including flame retardants and fluorinated chemicals in consumer products worldwide. Dr. Blum, welcome.
Thank you so much. Thanks to you and to the Massachusetts Breast Cancer Coalition for your good work to reduce environmental causes of breast cancer. And today I'm going to be discussing how classes of chemicals contribute not only to breast cancer, but to a wide variety of health harms. Let's see. So now I want to show my screen. It says pause on showing screen. So there's always a little AV thing. So where I say show screen, it says pause on showing your screen. Click to resume screen showing. Can someone help me figure out why I'm not showing my screen? When we practiced, it worked. Or
Dr. Blum, I do see your screen.
Oh, you do? Okay, I didn't. Okay, now I do. Perfect. Thank you. Okay, very good. So I'm going to start. Now I was confused. Okay. Just by telling you a little bit about the Green Science Policy Institute, we are scientists who do scientific research, communicate our research, and then bring people together from business, government, academia, and NGOs who share our passion for reducing harm from everyday chemicals. And our goal is changing government policy and also business practices to reduce the use of chemicals known to be harmful. So I'll tell you a little bit about my background. Back when I was a student in the 60s, date myself, my freshman chemistry professor was an inspiring young woman who had a doctorate in chemistry. And there were 4 girls in my freshman chemistry class, and we all got doctorates in chemistry, which shows the value of role models. I also started mountain climbing when I was in college. This was at Reed College in Portland, Oregon, and climbed high mountains from all over the world and did chemistry until a very sad climbing accident in India. One of the country's best climbers, who was an environmentalist, fell to his death on a high peak. And I decided I wanted to do something for the environment in his memory, and went to a professor of mine, Bruce Ames, who had a test for determining if chemicals were likely to cause cancer. And he said, could I please study a chemical called brominated tris? In those days, the 1970s, it was used in children's sleepwear. All the kids in the country were wearing sleepwear where the fabric was as much as 10% by weight, this chemical brominated tris. And we found a little girl who'd never worn the brominated tris in her pajamas. Her mom had bought her PJs in the UK. And so we put her in the pajamas, and the first day there was tris breakdown products in the little girl's urine. And every day she wore the pajamas, the level of tris breakdown products went up, and she stopped wearing them and it went down. So that meant the tris was getting into the child. Chemicals that we eat, foods, drugs, pesticides, are usually regulated. You could argue how well they're regulated, but they are regulated. But at those days at least, and still now to some extent, chemicals that are used, say, as flame retardants are not well regulated. So we realized this was a huge problem, that all the children are wearing a chemical that got into their bodies that changed DNA and was likely to cause cancer. And so we wanted to tell the parents of America about this. And then I got invited to this mountain. This is Mount Everest. And in those days, Mount Everest had only been climbed once by Americans. We were the second American Everest expedition. And I actually was getting a chance to be the first American woman to attempt to climb Mount Everest. So I had a big decision. Did I stay and tell the parents about the tris-treated sleepwear, or did I go try to climb Mount Everest? And I actually did both. So here I am in the Khumbu icefall on Mount Everest, crossing big ladders, climbing steep ice faces, carrying loads up high on Everest. And every night I'd get to my tent and I'd write my paper about the Tris and Kids pajamas. Here I am at my high point. This was about 24.5 on Everest. And we reached the summit. We were the second American team to climb Everest. And I sent my paper, the draft of my paper, from base camp to Kathmandu by mail runner, and it was published in Science as a big lead article back in 1977. And the subtitle says something about the work we do at our institute. The main flame retardant in children's pajamas is a mutagen and should not be used. And if people hear you read scientific papers, they always end with a recommendation like more study is needed. And they don't often end up with such a strong recommendation that this chemical should not be used because, as the title says, it was a possible cancer hazard. So after we wrote the paper in January 1977, 3 months later, in April, the Consumer Product Safety Commission banned tris-treated children's products, which was a wonderful thing and happened in a timely fashion, 3 months. However, when I checked to see what was then in the children's pajamas, I bought a lot of 30 pairs of pajamas and tested them, and there was still some brominated tris left over, but the replacement was chlorinated tris, which was similar in structure, function, and unfortunately also cancer causing. And so we wrote about this, and chlorinated tris was also removed from kids' pajamas. But we didn't know that it continued to be used in furniture foam until 2012 and in automobile foam until about 2015. And so our population did continue to be exposed, though not from pajamas. Anyway, at the time, I thought the problem had been solved. And also at that time, women had climbed many mountains, but not the highest mountains, 8,000-meter peaks. And I wanted to give some women an opportunity. I applied for a permit for a mountain called Annapurna, which is the 10th highest mountain in the world. It was the first of these high 8,000-meter peaks ever climbed. So I thought it was the first one climbed. It must turn out to be not too hard, not too dangerous. Unfortunately, Annapurna has since been shown to be the hardest and most dangerous of the 8,000-meter peaks. But fortunately, we didn't know that. We did climb it. I wrote a book called Annapurna Woman's Place about the climb, and then spent a long time writing a book about how I got into Annapurna, about my childhood, and I wanted to call it Mountains and Molecules. It was about mountain climbing and chemistry. But when I finished writing Breaking Trail, I had not done science for quite a long time and learned at that point that the same tris that we had gotten out of kids' pajamas was back in the nation's furniture foam and automobile foam, and started our institute. So a question I think of interest to this audience comes from this graph that I recently saw on the share of population with cancer versus the gross national product per capita. And this is up to 2017. But you can see, unfortunately, the US has about twice or more the cancer rate in terms of the share of population with cancer compared to European countries, most countries. So we can talk about this at the Q&A. Why would the US and Canada have so much higher cancer rates than all these other countries? So one reason for cancer worldwide is that there are more than 80,000 chemicals on the market today. Most of them are fine, but a few are harmful, and it's really hard to know which, and it's hard to regulate chemicals. If a chemical is shown to be harmful, it takes years of advocacy and science, and finally a chemical is phased out, and it's often replaced with what we call a chemical cousin, something really similar in structure, function, and toxicity, just like the brominated tris in kids' pajamas was replaced with chlorinated tris. Another example, on the left, we have a chemical called decabromodiphenyl ether, which was used about 15% of the weight of the plastic in televisions was this decabromo ether. It turns out to be persistent, accumulates up the food chain, toxic. And when it was shown to be harmful, it was voluntarily phased out. But as the sales of the decabromo ether on the left went down, the substitute is the decabromo ethane on the right. Looks similar in structure, equally or more persistent, bioaccumulative, and increasingly found to be toxic. So this is not a way to solve the problem, but changing industrial processes is expensive. So these drop-in regrettable substitutes are commonly used and certainly problematic. So what do you do when you have tens of thousands of individual chemicals? It seems impossible to make an impact. So we had a first retreat with people from government, industry, business, academia, who really cared about reducing harm from chemicals. And we came up with the idea of grouping the chemicals into classes or families with similar characteristics. And thinking about tens of thousands of chemicals is quite overwhelming, but thinking about 6 groups or classes is manageable. And what are the 6 classes? PFAS and antimicrobials and flame retardants, which we're going to talk about today, and also bisphenols, phthalates, some solvents, and certain metals. If you want to learn more, we have a website called 6classes.org, and there's a 4-minute video around each of the 6 classes and an introductory video, and we talk about where the class is used, why it's harmful, and ways to reduce exposure, to reduce using the class. And we put in a success story in each of the 6 classes, so this is not too discouraging. People are sometimes really upset. They discover that their everyday products contain chemicals that are known to cause cancer and other health harms. So when a chemical's in these classes, you don't necessarily never use it, but maybe you reverse the burden of proof. Now chemicals are believed safe instead of, unless they're shown to be harmful. And we like to say if chemicals are in the 6 classes, let's consider them harmful unless shown to be safe, and then ask, is this chemical really necessary? Is it worth it? And is there a safer alternative? So we're going to start with the first class, PFAS, which stands for per and polyfluoroalkyl substances, a bit of a mouthful. And the 2 previous commonly used PFAS were what was called the C8s, 8 carbons surrounded by fluorines. PFOA is 8 carbons with an acid, a carboxylic acid at the end of the top structure. And then below it is PFOS, PFOS, which is 8 carbons with a sulfonic group at the end. And why? I like to say that PFOS is my favorite class because it's the very worst and sometimes the very best. And the reason that PFOS are so bad and so good is the carbon-fluorine bond, which is very, very strong, and it's hardly broken. It takes the energy of lightning to break that bond. So these chemicals, the PFAS chemicals, never break down. They are some of the most, well, they're called forever chemicals. They last for geologic time. Also, the strong bond leads to oil and water repellency and good qualities. So where are PFAS used? They were used, but are no longer in a wide variety of products. I mean, I think the good news, which we'll talk more about, is the #1 source of exposure for children used to be carpets, but carpeting doesn't contain PFAS, nor does carpet cleaning products. They just read last week that the FDA is phasing them out of food packaging. They're used less in furnishings and cosmetics, outdoor gear, all these uses. The use of PFAS is phasing out, which is a really good thing. The bottom right, firefighting foam, PFAS has been used to fight oil fires, and a lot of practices were carried out where huge amounts were used for practicing firefighting and ended up in water supplies and groundwater in communities around airports and military bases. And there's been a lot of drinking water contamination from PFAS, particularly in low-income communities, a real environmental justice issue. So PFAS are in nearly all of us. It can be detected in the blood of 98% of Americans, and they unfortunately cause a wide variety of health harms. Several kinds of cancer, but they also harm thyroid, liver, pancreas, kidneys. So many organs are harmed by PFAS. So I first started reading about PFAS when more than 10 years ago, I was trekking in Nepal and reading this book, Stain Resistant, Nonstick, Waterproof, and Lethal, The Hidden Dangers of C8. And I was shocked, and I happened to be trekking with Anna Sharman, a Swedish woman who was a chemist, an analytic chemist who studied PFAS. And so everything I read in the book, she said, oh, it's worse than that. And I came back realizing something needed to be done about PFAS. I Googled and it was hardly mentioned anywhere. So I started a call with scientists from around the world. And we've been having calls once a month to talk about the science and policy of PFAS since 2013, over 10 years. And a lot of good work has come out of those calls. One of the first things we did was the Madrid Statement on PFAS. That was at a meeting, a dioxin meeting in Madrid, calling on the international community to limit the production and use and find safer alternatives. That was signed by more than 200 scientists, published in Environmental Health Perspectives. And we did a lot of communication. This was the first time that PFAS really came to national media, National Geographic. Nick Kristof in the New York Times wrote about it. There was a wonderful series, The Teflon Toxin by Sharon Lerner. But the thing that really changed everything was a New York Times magazine cover story about a lawyer named Rob Bilott, the lawyer who became DuPont's worst nightmare. And people read that and they were really concerned. And I later learned from the author that right when his story came out, the New York Department of Conservation and Health wrote the EPA asking them to take action on PFAS in drinking water and groundwater. And they asked for a variety of things like a health advisory level, listing PFOA as a hazardous substance. These things are actually finally happening. Like now, the EPA is managing to do some of these things. It's taken a long time, but it started back with, I think, the Rob Bilott article in the New York Times. I, at that time, wrote an editorial for Science, again, talking about regulating whole classes of chemicals and asking, do we need this chemical given the potential for harm? So one of the early things that came out of our scientist group was this map showing areas with high levels of PFAS and tracing back to the likely sources, which were industrial production sites, military training areas, airports, and wastewater treatment plants. The wastewater treatment plants don't produce it, but they get it from upstream and then have to figure out what to do with it. So some examples of the contamination from PFAS. In Michigan, Wolverine made hush puppy shoes in the 50s and treated the leather with Scotchgard, which is PFAS. And testing showed levels of PFOA and PFAS up to more than 800 times of the US EPA health advisory level. There were lawsuits, and Wolverine paid Michigan nearly $70 million for contaminating Michigan. And then they sued 3M, who made the chemicals and didn't warn them, and they paid Wolverine. So that was the beginning of so many lawsuits. Treating the water is really expensive. North Carolina has a then DuPont, now Chemours plant in the Cape Fear area that has contaminated the drinking and groundwater. And just to build carbon filtration plant, which filters out the long PFAS, the C8, it's $46 million to build the plant, nearly $3 million a year to operate it. And then to really deal with all the whole witch's brew of PFAS, you need reverse osmosis filtration. And Brunswick County, with only 25,000 customers, got an estimate of $100 million to build a reverse osmosis plant, and again, $3 million a year, which for a small county, not wealthy area, is just prohibitive. So out of all this, we've concluded that PFAS are problematic, difficult to clean up, and once they're out in the world, there's not too much you can do. So preventing is preferable. And just while I think of it, I don't see a slide, but I wanted to say that the story of PFAS, the same story that was in that New York Times article, was told in a wonderful movie called Dark Waters, where the lawyer Rob Bilott is played by Mark Ruffalo, and his wife is played by Anne Hathaway. And it came out just before the pandemic, so not enough people saw it. But if you get interested in PFAS, I really recommend watching the movie Dark Waters. So how do we prevent PFAS? Well, it's products. We need to stop putting it in products. And a real leader of that is a shoe company called Keen. We worked with Keen, and they wanted to remove all 6 classes from their shoes. And when they looked at PFAS, they found PFAS in 101 places in Keen shoes. 70 of the places, the PFAS weren't necessary. They said, we're water shoes. The shoes can get wet. And they removed those 70 places, the PFAS, right away. But then the other 30 places took years of work to find replacements and a lot of money. But they were successful because we tested many brands of shoes a few years back. And at that point, the only brand that had no PFAS were the Keen shoes. And Keen went one step further. They made a Keen green paper telling other outdoor and shoe companies how they could reduce the PFAS in their products more quickly and with less expense from what Keen had learned. So if you're interested, you could Google Keen green paper on PFAS and learn how. At our institute, we write scientific papers and use them to affect change. One example is back in 2017, we realized that PFAS was being used in a lot of food packaging. And we got food packaging samples from around the country, tested for PFAS, wrote a paper finding PFAS in nearly half of the fast food packaging that we tested. We had a one-day workshop with people from the food packaging industry who'd had no idea that they had PFAS in their food packaging. And they were really started back then, this was 2017, to take action. There was someone there who was in charge of certifying that packaging was compostable, and he immediately changed his rules for compostable food packaging to say that it could not contain PFAS. So this paper started things happening right away, the paper plus our meeting. And we did a lot of press about finding the PFAS in the packaging. Senator Blumenthal from Connecticut wrote the CEOs of the various food packaging fast food companies like Burger King here in this example and said, you know, why are you using PFAS? It's harmful. Well, Senator Blumenthal didn't hear back. We asked, but we later heard that a number of these companies, as soon as they heard about this, you know, our paper, our meeting, the letter from Senator Blumenthal, started working to find alternatives and to stop the use of PFAS in their packaging, which has since happened. And indeed, there's been a lot of food packaging PFAS bans, starting quite quickly with Washington State in 2018, and as early as 2019, Maine banned it, and the country of Denmark, they were the first country to ban PFAS in food packaging. In 2020, the US military in the National Defense Authorization Act included that there would not be PFAS in the what's called the military meals ready to eat. Then other states have banned PFAS, and just last week we saw that the US FDA had gotten an agreement that PFAS would not be used in paperboard and certain classes of food packaging. So this is a good example from a scientific research paper to a lot of policy action. And we don't want PFAS in our food packaging for sure. Another example is PFAS in carpeting. That was said to be the largest source of exposure for children, that you could link PFAS-treated carpet to higher PFAS blood levels. And so we wanted to do something about this, and we wanted to talk to the PFAS, I mean, the carpet manufacturers, they're all in Georgia. And so we have our Material Buyers Club, which are all these big companies who would like healthier environments for their workers, and they're using their cumulative buying power to require transparency from manufacturers and to show a demand for healthier products and materials with reduced use of these classes of chemicals. And so, and they're big purchasers of carpet. So we wrote the letters, but our Buyers Club members sent them to the carpet industry companies. They're all, as I said, in Dalton, Georgia, and they all came to Berkeley. And we had a one-day meeting. And at the beginning of the meeting, the companies were all saying, well, we went from a long chain C8 PFAS, which was phased out in 2015, to the short chain C6 PFAS, and we've solved the problem. And we explained that the C6 was likely to be one of these substitutes that had similar health problems. And by the end of the day, the carpet industry, they were pretty much all there in Berkeley talking about it, agreed at the end of one day. It was really amazing that they would stop the use of PFAS in carpeting. And that was in 2018. And they'd agreed to stop it by January 1st, 2020. And we knew it had worked. This is an ad, not an ad, an article, sorry, Michigan Public Radio, September 2019, that Home Depot was phasing out selling rugs and carpets containing any PFAS. And the reason Home Depot could phase it out is because the manufacturers had a couple years earlier committed and found alternatives. Now, you can ask, what are the alternatives? Are they really safer? Unfortunately, we don't know what they are. There's still what's called confidential business information, but we know they don't contain any fluorine carbon bonds. They're hydrocarbons, and they're likely to be better. Not having PFAS in carpets is definitely a good thing. So one more example. 3 years ago, we did a paper looking at cosmetics, and over half the cosmetics we tested did contain fluorine, which is a marker for PFAS, particularly things like waterproof mascara, shiny foundation, shiny liquid lipstick. And for cosmetics, there's direct paths into our bodies through our tear ducts, through inhalation, and through ingestions. And then lots of indirect paths where they end up in the environment. So this is a real problem. The day our paper went online, we had worked hard, and in the Senate and the House, bipartisan, the No PFAS in Cosmetics Acts were introduced. And that we had a press conference we'd invited the cosmetics industry, and a lot of companies came, and they had Senator Blumenthal and Debbie Dingell telling them to stop using PFAS in cosmetics. So the legislation didn't go anywhere at that time, but the cosmetics industry heard, and a number of companies agreed and stopped using PFAS. And then 2 years later, in 2022, California passed the PFAS-Free Cosmetics Act, banning all PFAS from being intentionally added to both cosmetics and personal care products sold in California. And there have been follow-ups in other states. And this really has had the effect. The state regulation can be much more effective and much quicker than federal. And PFAS are being removed from the nation's cosmetics because of this and other state laws. So a final example is textiles. We did a study of school uniforms, and I hadn't realized, but like 20% of American kids wear uniforms, and particularly low-income kids. And all the stain-resistant uniforms we tested had high levels of PFAS, which obviously you really don't want children to be absorbing the PFAS from their clothing. At the same time, there was legislation in California to ban PFAS in textiles. And I think our paper helped move the legislation along. The legislation was doing pretty well before our paper even, for sure, but that the legislation passed. And this is really a big deal because textiles are, furniture textiles, children's uniform textiles, and outdoor gear. And outdoor gear was especially interesting to me because I'm an outdoor person. 10 years earlier, when I had come back from my trek in Nepal, I started trying to talk to the outdoor industry about stopping the use of PFAS in outdoor gear. And they really did not want to talk to me because they felt they needed it for performance. But just a couple months after the California legislation passed, we brought the outdoor industry together here in Berkeley again at the David Brower Center to talk about how they would remove PFAS from outdoor gear, and they are. And so this is a good thing. And again, the carpeting is fine without the PFAS. The outdoor gear is fine. Sometimes you need a level playing field to persuade companies and industries that they really don't need PFAS. So if you are as interested in PFAS as I am and you want to know a lot about it, we have a website called PFAS Central. And every week we change the entries. with the best, most important news about PFAS, scientific papers. We read the papers, pick the important ones, and write a sentence or two, translating it into easily understandable language, and policy of PFAS, jobs, events. And our most important page is our PFAS-free page, where we list brands that do not, or certain lines of products that don't contain any PFAS. We've done that for the communities that have had contaminated water for sometimes generations, that are near military bases and airports, or PFAS production facilities. And the community said, it's bad enough we've had PFAS in our drinking water. We really want to buy products without it. So this is our most popular page. So you can go to PFAS Free or to PFAS Central and learn about which brands do not contain PFAS. Okay, I'm going to tell you quickly about one more class of chemicals. This is flame retardants, and we can ask, do flame retardants save lives, or do they cause harm? And flame retardants are used in TV cases, building insulation, textiles, children's car seats, mattresses, carpet padding, fabric blinds, paints, coatings, wire, cable, transportation, gym foam blocks, furniture foam. They were. Some of these uses, again, they're no longer used in furniture foam, which means they're no longer being reused in rebounded carpet padding. They're not being used in children's products so much. Some car seats no longer have them, so they're on their way out, but not so quickly, because with flame retardants, it's all about standards. And if you ban a flame retardant, there's always another flame retardant. So you have to change the standards that lead to the need for flame retardants to reduce their use in all these products. So an example of how flame retardants are contaminating the world is a map that we recently made showing animal species contaminated with flame retardants. And this is 150 different species, but it's only a small portion of the peer-reviewed science finding PFAS in mammals, birds, fish, endangered species, sadly enough, and in all the continents. So if you can Google flame retardants in wildlife if you'd like to see it, our map. So I'm going to start by talking about a California standard called Technical Bulletin 117 that was the California standard, but it was the only standard in North America. So it was pretty much followed across the US and Canada, because California is a big market. And it is a standard that led to the foam in our furniture and children's products being 5% by weight, a harmful flame retardant, which when I started this work was the same chlorinated tris that we'd gotten out of kids' pajamas. So I had a long memory and knew it was harmful, and most people didn't realize that. And the sad thing, this chlorinated tris turns out to be both cancer-causing and a neurotoxin. In fact, the improper use of flame retardants, the chemical it replaced, which was called a PBDE, harmed neurological development of kids. So, these flame retardants in all of our furniture, foam, children's products, automobile foam have really had severe health harm and do not provide a fire safety benefit, because the requirement was the foam had to withstand a small open flame for 12 seconds. But if you have a fire, if you imagine a candle falling on your couch, the fabric burns first, and then you have a big flame, and then the foam will burn quickly. And so there's really no overall fire safety benefit. The chemical that was used originally, that's right, is PBDE, which is, see if I'll point to it. Let's see. So that's a PBDE, polybrominated diphenyl ether, and it's halfway in structure between a PCB, known cancer-causing chemical, highly persistent, and dioxins, which are also cancer-causing and highly persistent. So this chemical was primarily used in North America from 1975 to 2004 to meet the California standard. The average American child has lost 3 to 5 IQ points from the PBDEs. And someone calculated a large loss in annual productivity from this. The flame retardants come out of furniture, drop into dust. We eat a sandwich with dust on our hands. We eat flame retardants. Children crawl in the dust and put their hands in their mouths, and they're eating flame retardants. And then cats who groom themselves have really high levels from licking their fur. Children can have 3 to 5 times the level of their parents because of their putting their hands in their mouths activity. So we get our doses of flame retardants by ingesting them. The PBDEs are associated with a wide variety of health problems. Pregnant women would be the most vulnerable. It changes their thyroid hormones that can lead to the lower IQ and various reproductive and neurological problems in their children. And in addition to not providing fire safety benefit, when you burn flame retardants, you get a lot more soot, smoke, toxic gases like carbon monoxide and hydrogen cyanide, and at the end, dioxins and furans, which likely contribute to cancer in firefighters. So the flame retardants do not help with fire safety, but make the fire more dangerous and ultimately more harmful. Firefighter deaths are sadly more from cancer than other things, and firefighters are healthy young people. They have an unduly high cancer rate, and it's believed that the dioxins and furans from flame retardant burning could be contributing. So we compare a couch with foam with flame retardants. It meets the California TB 117 to one without flame retardants. There's really not much difference in the burning behavior, but a lot more toxicity from the flame retarded couches. So we, having remembered in the 70s how it took 3 months to remove the flame retardants from children's pajamas after we wrote a paper about this. We wrote a number of scientific papers. There was legislation, 4 bills in California, and we had a solution that would increase fire safety without flame retardants, but all of our bills were defeated. Those were the days when I started the Institute, and I was working for free and, funded our Institute. And at the chemical industry had huge advertising campaigns. The deadly mistake, don't let Sacramento politicians ban the use of proven flame retardants. This was part of a big advertising campaign when one of our bills almost passed. And we heard a journalist did research and found that the chemical industry spent over $23 million in California preventing regulation to increase fire safety modestly without flame retardants. So one of our papers, we looked at 100 baby products, and 85 had flame retardants. There were things like a baby's changing pad that was 15% by weight, chlorinated tris, the same chemical that had been in kids' pajamas. And this drew a lot of attention to the flame retardant problem. We had support from industry. This is the Office Furniture Association, Business and Institutional Furniture Manufacturers. And when they learned how harmful the flame retardants were, they came on board supporting us. Ultimately, trade associations for home furniture, business furniture, fabric, juvenile products, they all supported changing the California standard so flame retardants would no longer be needed. But the thing that changed everything was a series of articles in the Chicago Tribune. The subtitle of the first things are all front page stories. The subtitle says it all. A deceptive campaign by industry brought toxic flame retardants into our homes and into our bodies, and the chemicals don't even work as promised. This is an old series now, but very interesting, talking about the duplicity of the chemical industry and continuing to promote these chemicals, which did not provide a fire safety benefit. After that series came out, it provided good coverage for our governor, Jerry Brown, to change the California standard to increase fire safety without flame retardants. So couches will have labels that checks contains no added flame retardant chemicals. And this indeed has become a national standard. There was a big struggle about making it a national standard. And then finally, one of the 1,500-page COVID bills, the last sentence is the COVID Work from Home Safety Act, which said the California standard would become a national standard, which means increased fire safety without the need for flame retardants. So that was implemented in June 2021. Quickly, a couple recent things. Way back in the 70s, I wrote that we didn't need flame retardants in our tents, and the outdoor industry has been working. They don't want to put flame retardants in tents. Mountain tents don't need flame retardants. You know, if for some reason you would catch your tent on fire, it would just melt away. You don't want these chemicals that you're breathing when you're sleeping in the tent, or you're getting on your hands when you're pitching the tent. And finally, last October, California passed the No Toxics in Tent Act. I think the only states that still require flame retardants are New York and Minnesota, and they're in progress of removing them. So soon, hopefully, we will not have toxic flame retardants in our tents. Another thing I wrote about in the 70s was brominated vegetable oils, that we did not want these in our soft drinks. And they were added to citrus drinks to give a cloudy look of real fruit juice. But they've been banned in the EU and Japan. And finally, last October, we did ban brominated vegetable oils. We're working now on flame retardants in vehicles. I think I'm about over time, so I'll just say that though flame retardants are out of our furniture, they're still in our cars. There's no proven fire safety benefit. We're exposed. And again, we did a study of 100 cars. The results are going to come out in about a month, and we found multiple flame retardants, some of which are known carcinogens and neurotoxins. So this is a big challenge, changing the flammability standard for cars, but we are working on this now. And another problem is e-bikes. There's lots of e-bike fires in New York City. And to deal with that, New York made a standard to prevent e-bike fires, which is a really good thing, except, and most of it is good, it's preventing the causes of the fires, but it also says that the batteries have to be wrapped in flame retardant plastic, which, as we know, a fire from a lithium ion battery is so energetic that won't make a difference. And the flame retardants, again, make the fire have more soot, smoke, and toxic gases. So we really do not want flame retardants in our e-bikes, and we are working on that right now. Okay, well, just to say, so we've done lots of work on flame retardants in lots of places, and I'd say vehicle interiors and e-bikes are what we're working on. Okay, just a quick word about antimicrobials, which are overused, especially since the pandemic. And A project we're working on is the fact that in gyms, they say to wipe down equipment after every use with spray bottles, and the spray bottles contain chemicals called quaternary ammonium compounds. And we've just written a paper. Oh my gosh, just says my computer is running out of batteries. I hope I have enough time. Sorry. It says I have 6 minutes. 6%. I'll be okay. Okay. Anyway, so it turns out that plain soap and water kills most germs, viruses, bacteria, and that's what people should be using in their gyms. And if there really are needs for disinfection, that should be done by trained gym personnel wearing protective gear. So another one of our current projects that I will not talk about too much right now. Last interesting op-ed we had in the New York Times a while ago, saying how when we reduce the use of carbon for gasoline, it's being used more to make plastic and toxic chemicals. And so the petrochemical industry, is causing climate change, plastic pollution, and a lot of these toxic chemicals. So these all work together, and that's another issue, that sustainability it should include climate change, plastic pollution, and reducing toxics. So my glamour slide, sometimes working on flame retardants can be glamorous, and for the work we did changing the California standard, I got inducted into the California Hall of Fame with, on the far left, Robert Redford, and on the far right, Joan Baez, two of my big heroes, and a lot of other wonderful people. So reward for science and policy. Remind you to take a look at the 6 Classes videos at 6classes.org for healthier products, healthier people. Watch the 4-minute videos. So if you want to learn more, we have 4 websites: greensciencepolicy.org, PFAS Central for the latest on PFAS, 6classes.org to watch the videos, and I have my own website, arleneblum.com. We have monthly newsletters. If you go to any of our websites, you'll get a screen and opportunity to sign up. We're just sending one out today, and I hope you'll stay in touch by signing up for our newsletter. So I'll just end with a picture I took from with Mount Rainier in the distance from a high mountain meadow. Reducing the use of 6 classes, we can have a healthier world. And you can learn more at Green Science Policy. So thank you very much. And I will turn off my screen.
Thank you, Dr. Blum. That was really such an informative presentation, because you gave us really that whole historical perspective on this work. And I was thinking how you, being a mountain climber, made perfect sense, because you need perseverance and resilience and tenacity, all of those personal qualities necessary, I think, for the type of environmental advocacy work you have done throughout your career. So thank you for informing us a little bit about you, but also giving us that incredible historical perspective on this work. I will invite any of our audience participants on the webinar today that if they have any questions, they could go ahead and post those in the question drop-down menu that it should be on the side of your screen from the GoToWebinar. And if you pop those questions in, I'll be paying attention to that. But if I could start off with Dr. Blum, you mentioned early on around that, the US seems to have twice or even more of the per capita number of people with cancer compared to other countries. Can you tell us a little bit more about that and why that we might be seeing that?
Hi, well, can you hear me? Because
Yes.
my battery ran out and I managed to plug it in, and I see a blank screen where I am, but anyway.
We can still hear you, thank you.
Oh, okay, yeah, I should have Oh, it says, let me just try show screen. Oh, well, anyway, you can hear me, so that's good. So, I like to say that having done years of climbing, and I spent a year once walking across the Himalayas, that I no longer can do high mountain expeditions, but what I'm doing now feels just like a high mountain expedition, because you have a goal, be it the summit of Annapurna or our mutual goal is a healthier world with less cancer-causing chemicals. You find a team of people who share your passion. You pick up heavy loads and then you plod up the mountain. It's not that glamorous. It's hard work. And along the way, there's storms and avalanches and an occasional Yeti pops out. So it's a very similar process. And anyway, I'm trying. Oops, I hope you still hear me. I was trying to click and get my picture.
We can hear you.
You can hear me, and who knows what? Oh, I know. It's I have to turn on my camera, but I won't try right now because it's probably too hard. Okay. Let's see. Well, that doesn't work. Okay. Anyway, so I feel really lucky to have found something that's like mountain climbing that I can do as I've gotten. It did work. Hello. Should have plugged in my battery sooner. Anyway, so I do feel fortunate to have found a similar sort of endeavor, and I think we're all roped together, all the people who are part of your organization, and our goal is a healthier world. And so I feel really lucky to do work that can make us all healthier.
And why is it you think that in the United States, our rate of cancer is so much higher than other countries?
Well, it is a good question, and I don't really know the answer, but my speculation, I mean, cancer is genetics, and I don't think our genetics that different. It's lifestyle and then exposures. And I think we do have a lot more of these chemicals. The flame retardants in furniture were not used in Europe, but they're used in the US. I think we use more PFAS. I think perhaps our food supply, I've heard highly processed foods are not helpful. So I think it's a combination of exposures and lifestyle. And I feel really fortunate to have work that helps address that. And I think that is a reason why the work of your organization and our organization are so important, because the US should not be having, it looks like almost twice the cancer or more of most other countries. I was really surprised when I was showing that graph.
Wow. And and yet, as you have been doing your work and presenting your work today to us, you sound very optimistic that we can be successful at preventing cancer from chemicals. Where does that optimism come from?
Well, the stories I've told you, PFAS, we were all being exposed to PFAS, and now it's, phased out of the major, it's not in carpets, food packaging, cosmetics, textiles. So we can do things that help. And I feel really lucky. I actually stopped doing science in 1980 when Reagan became president. I thought I'll walk across the Himalayas and I'll go back to science in 4 years. And then I had a family. I didn't go back to science till 26 years later in 2006, thinking I couldn't do anything useful. And then what a privilege, to have had the opportunity to really make a difference. So I'm a big believer that science can make a huge difference. We also really like to encourage other scientists to use their science to reduce the harm of chemicals. And it is linked, it's another topic, but it's linked to plastic pollution and climate change. It's all part of the same thing. So I think we've defined the problem. The solutions are hard, but once you have defined your problem, found your mountain, and starting to climb up it, there's an optimism that we can make a difference. So, and your organization is making a difference. So I think it's a real privilege to be able to do that.
That's a great analogy, and we did get a shout out for you from someone who was working in the industry. And early in your presentation, you talked about being in a lab with other young women who you had a woman educator who was a role model for you and for the other women in your class, and how important it is to have that representation in the work, in the field, in education, as well as in advocacy work. I'm very happy to hear that you were inducted into the California Hall of Fame. We did get a question from our participants. I am concerned about the water supply. A trusted spring water supply recently closed down operations due to PFAS in the water. Do you want to comment about that the PFAS became so prevalently used that it actually was showing up in the water supply as part of the water cycle? And what should folks do to know for themselves how to maybe prevent future exposures when it could be as simple as, oh, it's now in our water supply?
Well, PFAS in drinking water is a huge problem, and it's been around for a long time. Remember, the hush puppies in the 50s led to this huge contamination in Grand Rapids, Michigan. And I think we and Rob Ballot and others helped draw attention to the PFAS problem, as I traced in my talk, and that people now drinking water people who provide drinking water are having to look for PFAS. Before it was being ignored, and it can be taken out by carbon filtration, and it's expensive. I mean, that's the reason that we want to stop using it in our products. So it's a huge problem, and depending on what health advisory level you use, we can say a lot of drinking water in the US is contaminated, and particularly people who live close to airports, military bases, and places where they produce PFAS. And the answer is to filter your drinking water. And then if you think about the environment, people can filter their drinking water, but what about the birds and the bees and the bats who are out there in the world who are all suffering big decreases in their numbers? Is that partly due to PFAS? It's likely. So I think stopping the use in products is all we can do, because it's too expensive. You can't clean up the whole environment. People can get safe drinking water through filtration at a price, and the environment and wildlife can't. So we have to stop using it, and that is happening. The state of Maine took the lead in banning the use, not till 2030, but it still shook everything up. Little Maine, the first place in the world, said companies have to report their PFAS and stop using it by 2030, and that has had huge impact. All these companies, like 3M, actually made a big document listing all the uses and is stopping making PFAS, which is great. So I think our states can take action, communities can take action, and that is happening, which is why I do feel some optimism that once we've defined the problems of PFAS flame retardants, I think the class concept really enables people to take action. When you have 80,000 chemicals, what can you do? But if you think there's 6 classes that are not all, but a big chunk of the harmful ones, you can think about the whole class. There's like 10 or 12,000 PFAS. And the chemical industry would like you to regulate them one at a time. And you know how long that's going to take.
Right.
But if you can regulate the whole class, and that's what's happening. Like Maine said, the whole class of PFAS, we need reporting of where it's being used, and we need it to stop. So that leads to some optimism, and water filtration can help humans, but not the world.
Thank you so much. I just want to read this comment because I think it really speaks to so much of your presentation today. It says, "Thank you so much for all you have done for the environment and the world. Your career is inspirational." This person writes, I'm a chemist working in environmental protection in New Jersey in the state government. So that, you are inspiring all of our listeners today and anybody else who's going to join us to listen to this webinar later on. So thank you so much for your presentation today and all your work. On behalf of myself, the Massachusetts Breast Cancer Coalition Board, and Cheryl Osimo, MBCC's Executive Director, I want to thank you, Dr. Blum, for this very informative discussion. And I want to thank all of our many listeners for joining us. For those interested in the recording of this webinar, it will be made available later today on the MBCC website at mbcc.org. If you would like to further support our mission of preventing environmental causes of breast cancer, please consider making a donation by visiting mbcc.org/donate. I appreciate your consideration. Have a good afternoon. Thank you, Dr. Blum.
Thank you.